Now let's look at some examples of applying these two ways of using scientific notation. So our first example is going to have us taking a number that's in scientific notation. You can see this one is of the form A. This 1.745 right here is our A. And it's getting multiplied by 10 to the third. So we're going to look up here at our directions. 3 is a positive n, so we're going to be moving our decimal point to the right. And because n is 3, we're going to move it 3 places to the right. So 1 and 745ths times 10 to the third is the same thing as 1,745. Going the other direction, here we have one where our A is 1.07, and it says times n to the negative 2. So when it says negative n, we're going to be moving our decimal to the left 2 places. So this new number is going to become so there's tens, hundreds, thousands, 10,000, so 107 10,000ths. Going from standard notation into scientific notation is just doing the reverse of what we did above. So here's a number that's written in standard notation. If we want to get it into scientific notation, the decimal right now is at the back of the number, at the very end. So in order to get it up to the place where our A fits the requirement of being between, because remember A needs to be between 1 and 10, we're going to have to move the decimal 1, 2, 3, 4, 5 places. So I'm going to rewrite this number as 1.5 times 10 to the 5th. My n is positive because the number I was started with was a large number, and large numbers have positive exponents. Doing this one, I'll use the same process. My decimal's out front this time, and I see that I need to move it 1, 2, 3, 4, 5 places again in order to get A to be somewhere between 1 and 10. So I want to move the decimal until there's only one non-zero digit in front of it. So it becomes 6 7/78 times 10. Since this number was a very small number, my n's going to be a negative number. So it's negative 5. Now let's look at 2 more examples, or 4 if we've got time in this video. What do you do when you have a number that sort of looks like scientific notation? It does have this times 10 to the negative 7, but my A here doesn't meet the requirement, because remember, A has to be somewhere between 1 and 10, and this A is at 495. So for this problem, let's first stretch it out and look at what it would look like. This negative 7 says I'm moving my decimal 7 places to the left. This number needs to get much smaller. So when I move that 7 places from the left, right now it's at the end. 1, 2, 3, 4, 5, 6, 7. This is going to become 1, 2, 3, 4 zeros, 495. And then when I go to turn that back into scientific notation, 1, 2, 3, 4, 5 places is all it should have moved. So if you notice, moving that decimal 2 places this direction actually made that number go up by 2. That 495 times 10 to the negative 7th is not a number that's in either standard or scientific notation, because scientific notation has the times 10 to the n, but the A has to be between 1 and 10. So my method for solving that was to first turn it into standard notation and then convert it to scientific notation. Let's see if we can do that with a large number. 54 times 10 to the third would be 54,000, because the times 10 moves our decimal 3 places to the right. Turning that number into scientific notation, 1, 2, 3, 4, I need to move my decimal 4 places so that it's in between the 5 and the 4. So again, moving it that 1 extra space caused that 3 to go up to a 4. Applications of scientific notation might look like problems down here. Writing New York City's population as 8,200,000 takes a lot of zeros. So we could write this number in scientific notation by writing 8.2. So our A is somewhere between 1 and 10, and then counting the number of decimal places that had to move in order to have that be true, which is 6. Looking at the speed of a garden snail, writing 3/100 really isn't that difficult, but if this was a science class and they ask us to put it in scientific notation, we could write this as 3 times 10 to the negative 2, since I need to move my decimal 2 spots to the right in order to make this true.